Okay, so let's finish this up. We're gonna do a quick little presentation just to finish these last few slides that we have. I realized first period that they don't have all the dune shapes that I kind of promised we would talk about. So I pulled it up. It's not going to be tested on. There's no homework questions over it because apparently it's not in the book. It was not in the PowerPoint. So I guess I was remembering maybe teaching at OU or Cedar Valley. I know that we've taught this before, or at least I've learned about it. Apparently, my memory's not super great, but it's not in this book, so it's not a big deal. But I wanted y'all to see some of them, so I'll talk about those in a second. Yes, we're back on the PowerPoint, and we left off here yesterday. I need to calibrate my board with this desert pavement image, and I think I got through most of it, but I just want to go through it again. Just the idea that as the sand blows away, your larger rocks, and they don't have to be like huge, like pretty large rocks. They can be smaller size rocks. They will be left behind because the wind's not going to blow anything that large away. It's just going to blow your lighter sand away. And so as it blows those away, they kind of, it appears that they rise to the top, even though really everything that's kind of around them is being blown away. And so they all coalesce at the top of whatever layer you're eroding away. And so you get down eventually, maybe until you get all the way down to bedrock. And another weird thing that happens is as sand blows back into this area, so you can see as B, you have sand piling up. You would think that the sand would just pile up and cover these up, but that's not actually the way it works. If you put sand and like some rock or gravel in a container together and kind of just shake them up, the bigger pieces actually come up to the top. It always messes with my brain because you think gravity's pulling harder on the bigger pieces, they're going to sink down towards the bottom. But it's not really a liquid we're talking about. And this is more about physics and how the smaller grains go down underneath these rounded pieces and are able to kind of shift their way underneath and lift them up in a way. And so you can see that they kind of get elevated up above. And this is how you get this desert pavement. So uh, this is the process how you get these rocks all aligned on the surface of a desert area above the sand. So we're going to finish up with our wind deposits. What type of wind deposits we have? We have two different ones. We have one called loess and one called dunes. Dunes we're more familiar with because they're the sandy kind of stuff. And so if you've ever been to a beach, even if it's man-made, not man-made, but sand that's brought in specifically for that beach, the wind blows, especially near the ocean. The wind blows inland quite a bit, and it will build up these big sand dunes. Sometimes you got to kind of walk over them to get to the beach. But we have dunes and we have loess. Loess is going to be more silt. And so if you think back to sedimentary rocks, the mudstones and the siltstones had really, really fine particles, very small, much smaller than a particle of sand. So your loess is going to be your silt-sized particles, very fine. Your dunes are going to be your sand-sized particles. So this just talks about loess being wind-blown silt. It tends to erode in vertical cliffs, so they show this vertical cliff right here, which is made of loess. There's not really any bedding, so unlike a cliff that was made of some sandstone, where you would see the different layers, the loess just kind of piles up in one big pile. Deserts create a lot of this. Like we're familiar with the sand from deserts, but they also have a lot of silt-sized particles. And glaciers actually create a lot too, because as they grind down the mountainside, they create bigger particles, but they also grind a lot of really fine stuff. We even talked about the rock flour that they create. So very, very fine particles that blow away very easily. You don't have to have a lot of wind to blow something like silt away. And so it will travel and all pile up in certain areas, and you get your loess beds. So now we talk about sand. Sand accumulates in mounds and ridges where the path of wind is obstructed. And really, the sand is what is obstructing the path of the wind. Many dunes have asymmetrical profiles, and I'll actually show you this over here. I'm turning the lights on. Your sand dune, let me erase this and redraw it. Your sand dune kind of starts out, we're just going to start off here. This is not obviously how sand dune starts out, but Imagine you have a big pile of sand kind of like this. The wind blows. Even if the wind's blowing from the bottom, it's going to push this sand up over the top. And when it gets to this side and falls down, there's nothing really acting on it other than gravity. And so if you think back to the sediments chapter, when we talked about sediments and they talked about the angle of repose, that like angle that a certain size sediment will only pile up at that angle. And once it gets to that angle, the pile will just get wider and wider as it gets taller, but you'll always keep that angle because anything above that, gravity will pull it down and kind of spread out the pile. So this angle is kind of what controls the backside where there's no wind. There's nothing controlling it. And so what you get over time is the windward side gets kind of flattened out, and then on the backside, it just kind of falls off, and gravity controls that. And the more wind that blows up your windward side, these particles are going to come up here, and then they're just going to fall off. And it's going to kind of build out like this, layer after layer after layer. And so your sand dune is actually going to move this direction, or it appears that it's moving this direction as the wind blows. And so there's actually a lot of complexity in sand dunes. We have a couple terms. They have the leeward side. Leeward is sheltered. So this is the back side of the slope where the wind is not really blowing. The wind blows over the windward side, and it doesn't hit the leeward side. I thought I heard the beep of the announcements. And so you get this gently inclined slope on one side where the wind is blowing, and you get this very steep slope on the back side on your leeward side. Sand accumulates on the slit face. So the little faces that I drew kind of building out, that's going to be called the slit face on the leeward side. And the dunes migrate in that direction, the same direction the wind is blowing. Those little layers that you see that kind of build up are called cross-bedding. And we can actually see those in the rocks here. And that's what's really interesting about these rocks. And some sand dunes, not sand dunes, but sand that is built up on beaches or in like lagoons or shallow rivers. We can actually get direction of the wind and water during that time period. So let's say these rocks are like 100 million years old. If they're in place and haven't been like moved, they haven't rolled down a hillside or they haven't been lifted or moved in any way because of plate tectonics, these cross beds here literally show us the direction the wind was blowing 100 million years ago when these rocks formed. So we can know just how arid and just how windy these environments were looking at sedimentary rocks. And so they kind of have a progression here. Your wind is going to blow the sand up, and then it's going to drop down the leeward side. It's going to blow it up the windward side and drop down the leeward side. And as it drops down over and over and over again, you're going to get these beds that build up. So you're going to be able to see these different layers that build up here. Each season or in different types of the year, the wind's going to blow in different directions. Like here in Texas, during the summer, we get a lot of wind from the south, from the Gulf, which is what brings us all our hot weather. In the wintertime, our wind comes up from the central part of the country in Canada. It's that dry, really cold air. And so in the desert, you get the same thing. Depending on the time of the year or the weather patterns, your wind's going to blow in different directions, and you get all these buildups of these different cross beds, which you can kind of see here. You see go in one direction, so you come back another direction. Go back in one direction, and it just happens over and over and over again. So this is the last slide for the sand dunes. I thought that we were going to go into some of the shapes and stuff, but I just wanted to show you real quick. Again, this won't be tested on. There's many different unique shapes that the way wind can blow sand into a dune. For us here in Texas, we don't have a lot of sand dunes. We're just like a sand dune is a sand dune. It's a pile of hill or a pile of sand. But in the Middle East or the Saharan Desert or a place that has a lot of these, you would easily recognize that, there's this type and there's that type. And depending on which way the wind blows, it has this kind of features. And so you start off with your transverse sand dune. This is probably the simplest one that we're familiar with. Just your big piles of sand. The wind's usually blowing in one direction. This is probably something you would see near the beach, because usually when you have land and water, the wind is coming up from the water onto the land. But if you have more complex features, you can have different stuff going on. So you have parabolic dunes here, and they actually show the parabolic dunes near the beach. But they kind of have this parabola kind of look, and they're I guess they're concave, the direction of the wind. You have the opposite of that, which are Barken dunes, which are convex into the direction of the wind. So it's kind of like the opposite between the parabolic and the Barken dunes. You have linear dunes, which you have two different wind directions, not necessarily at the same time, but over and over the wind kind of changes just a little bit. And so it doesn't build up in the way that we see here. It kind of alternates and you get these linear dunes, and also a little bit of the Barken dunes sprinkled in. If you have wind that happens to change all sorts of directions all the time, you get these big star dunes. And these, I remember, are actually the biggest ones. If you ever see like a gigantic, super huge dune that's like hundreds of feet tall, that's because the wind changes all the time. And so you have some areas that kind of look like a star, and just the wind keeps blowing sand up onto this hill from all sorts of different directions, and it just keeps piling up. And so they can get really, really big. And then you've got these kind of scalloped Barken dunes becoming transverse dunes. And so depending on where you're at and how the wind blows and the way the sand piles up, you can have really, really complex features in your sand dunes that we probably don't get a chance to see all that often. So I just want to show that to y'all. That's the end of the presentation today. You're going to have some free time today if you want to work on the River Lab. It is due tomorrow at the end of the class. If anybody needs an extension through the end of the weekend, I will probably give it to you. I'm going to work on grading. I got some emails to answer, but I'm going to try to get some more grading done for y'all. The chapter 3 and 4 homework. So for these two chapters that we just finished, it is up, and it will be due next Friday when we take the chapter 3 and 4 test. More than likely tomorrow, we will start on the next chapter, which is going to be earthquakes, because it's pretty complex, and we're going to do a lab. And so I want to kind of get started on it, so we got enough time to take a day or two off to do the lab next week. Unlike the River Lab, it's going to be one that we're probably going to go over together, and y'all might want to do in class because it's a little bit more complicated and math heavy. So if you have any questions at home, please send me an email, and everybody have a nice day.